This is a video tutorial on linear functions part 6. In this video we'll be looking at the angle of inclination of a line. Another measure of steepness of a linear function is the angle made between the line and the x-axis. I've drawn two examples of what this might look like. Here we have some function f of x, a linear function, and we can measure this angle here. That's the angle of inclination. And we have another function here, g of x. We have the angle of inclination here. Well, since we have a decreasing function, this will be a negative gradient. So you'd imagine that this angle of theta would also be negative. Now, in order to calculate this, we look at the similarity and the relationship between trigonometry and the gradient. So, take a look. Here we have the angle of inclination, but notice how if we were to draw a right angle triangle using the rise and the length of the run, it draws out a right angle triangle like so. And then from this we can say tan theta is equal to opposite over adjacent, but the opposite height is the height of the rise, and the adjacent length is the length of the run. So we can say tan theta is equal to rise over run. But we already know that the gradient m is equal to the rise over run. Therefore, we can conclude tan theta is equal to the gradient, and theta, the value of theta, is the inverse tangent of the gradient. So it's this that we will be using to calculate later on the angle of inclination. So let's do two examples here. I'll leave this here for us. So let's get to it. So tan theta is equal to m. So for this function, we need the gradient. Fortunately for us, it's very easily provided here. It's 3. So our gradient here, m is equal to 3. Using our trig relationship, we get tangent, or tan theta, is equal to 3. Theta is equal to the inverse of tangent, inverse tan, of 3. In order to calculate this, we definitely need the calculator, so we'll use it now here. And we just merely type it in as shift tangent of 3, close bracket. This gives us a decimal value, but in order to convert it, we press this button here. Yours may look different. It looks like bubbles and dots, but when you press it, it converts it to us here in degrees, minutes, and seconds. To round this, if we round it to the nearest degree, we look at the minutes and notice that it is past halfway of 30. So we round this to 71 degrees, 34 minutes. So let's write this in. So we get theta is equal to 71 degrees and 34 minutes. Okay, so that is the angle of inclination here at 71 degrees 34 minutes. Okay, let's now get to the next example. Here we go. So once again, in order to calculate this angle, we need the gradient. So let's calculate the gradient between these 2 points first. So m is equal to, let's make this y2. 10 minus y1, which is 3, over x2 minus x1. This will give us 7 over negative 7, which equals to negative 1. So since we have the gradient, we can now write this relationship between tan. So we get tan theta is equal to the gradient of negative 1. Theta is equal to the inverse tangent of -1. Typing this into our calculator, take the inverse shift tangent of -1 equals, we get -45 degrees. Fortunately, this time it's given us a straight answer. Sorry, -45 degrees. Fortunately for us this time, it's given to us as a straight answer like so. But I hope you've seen the insight into calculating the angle of inclination using tangent and the gradient. Hope to see you in the next video. Best of luck.